In this video, we look at the computations needed for finding a confidence interval. Recall our example problem. Throckmorton P. Adderpate IV was a candidate for the distinguished office of assistant dog catcher. Gallup did a poll. They surveyed 400 voters, 168 of whom said they planned to support the candidate. And the question was, what percentage of all voters plan to support him? How do we answer that question? We, of course, begin by drawing a picture. Why do we draw this picture? Because it's stats class, Dr. Asp. We draw bell curves in stats class. Yes, we do, but why do we do so? Remember our earlier module on sampling distributions? One of the things we noted was the central limit theorem, that as we get large amounts of data, aggregate results will tend to follow bell curves. And so in this particular problem, we're looking for the possibilities for the true percentage of the voters supporting the candidate. And we don't know exactly what that number is. There's a range of possibilities. But the most likely possibility is what we got from our data, the 42% we observed. But we don't think the answer is necessarily exactly 42%. We're willing to give it some windage. Basically, we're trying to establish some boundaries, a lower bound, an upper bound, so that we're pretty sure the true unknown answer is in here. We're going to cover a certain percentage of the curve. And the percentage of the curve, the amount of confidence that we have, is up to us, but it's fairly traditional to look at 95%. Notice what we're doing here then. We're starting with a best guess, but we're going to go down from there and up from there, plus or minus on a bell curve a certain number of standard deviations to cover a certain percentage of the curve. In formula terms, then, we start with our best guess. We go plus or minus some number of standard deviations. And any intro stats textbook in the universe, when they cover confidence intervals, will have a section on a confidence interval for this type of problem, and a separate chapter on a confidence interval for this type of problem, and a separate chapter for a confidence interval on another type of problem, and they'll have a different formula in every single one of those chapters. But the thing to remember is that they are all deep down really the same formula. That every confidence interval we look at in bell curve world starts with the best guess and goes out from there a certain number of standard deviations. How many standard deviations? Well, remember, it's a normal distribution, and we have some benchmarks for a normal curve. What were those benchmarks? Start in the middle, go out one standard deviation. How much the data do we have? That was about 2/3 of the data. 2 standard deviations was 95% of the data. 3 standard deviations, virtually all the data. And in confidence intervals, we most commonly rely on that second factoid. Use a 95% confidence interval, go out around 2 standard deviations. At this point, I need to go on a slight tangent. You need to understand that statisticians as a group can be pretty OCD anal retentive. Strictly speaking, it's not 2 standard deviations, it's 1.96 standard deviations. Where did that number come from, Dr. Asp? Good question, glad you asked it. Let's draw a picture. We want 95% out of the middle of the curve. Remember how Excel sets up its normal distribution formulas. It bases them on a certain point on down. If this is 95%, there's 5% total out in the 2 tails, so 2.5 down here, 2.5 up here. So this portion of things is 97.5% of the curve. Our norm.s.inverse function tells us that if we want to be exact, it's 1.96 standard deviations. Now, I don't care whether you use 1.96 or 2 standard deviations. I'm fine with either number. Just understand that I tend to be a bit OCD about things. My solutions are based on 1.96. Not a big deal. So let's work out the solution to this particular problem. Remember, confidence interval is our best guess plus or minus some number of standard deviations. In this problem, 42% of the voters in the sample were supporting the candidate, 168 out of 400. We're going to go out from there 1.96 standard deviations, or 2 if you're feeling a tad more relaxed, to cover 95% of the curve. How big is a standard deviation in this problem? Well, the number we are analyzing is a proportion, and so we need the standard deviation for a proportion. Have we seen anything but in this or a previous life that tells us about the standard deviation for a proportion? Yep. In our module on sampling distributions, we noted that this quantity, p1 minus p over n square rooted, was the standard deviation for a proportion. And in this problem, we think p is 42%. If 42% favor the candidate, 1 minus that, or 58% don't. This was our standard deviation. Hit a few calculator buttons, 0.42 plus or minus 0.048. In other words, what does this mean? We're pretty sure. In other words, we are 95% confident that if we surveyed everybody in the electorate and asked them whether they support the candidate, we would find the percentage that does is somewhere between 42 minus 4.8, 37.2%, and 42 plus 4.8, 46.8%. We don't know exactly what the number is, but we're pretty sure the answer is somewhere between those boundaries. What percentage of everybody supports the candidate? We don't know exactly, but we're pretty sure we're 95% confident that it's somewhere between 37 and 47%. Notice, 42 plus or minus 0.048. We don't know exactly what the percentage is, but we're pretty sure that that candidate's losing, that the candidate does not have 50% of the vote. If, on the other hand, our interval were 62% plus or minus 0.048, we don't know exactly what's going to happen in that election, but we're pretty sure the candidate is winning. We're pretty sure the candidate has more than half the vote. What if it's 52 plus or minus 4.8? Yeah, the candidate appears to be leading, but there's enough uncertainty, there's enough margin for error that, generally speaking, we would say that election is too close to call. Remember that phrase. You'll see it often in discussions of poll results on elections. And so we worked through one example on finding a confidence interval. In the next video, we'll work through a couple more just to make sure we understand things.